Great. So next week meeting will be Tuesday. Also flip back to because no one will be in Hong Kong, so no more Hong Kong time. Then back to Monday, the week after that. And we can start with company update.
Yeah, so I think two things. One is we have some product launches in the pipeline. We have the one that we've talked about a little and the one that we haven't talked about at all. Uh, those are exciting. The other thing is if you search for TinyGrad now on YouTube, there's a lot of videos.
Is it the same or similar thing to the previous one?
Um, kind of. It's like things like this. There's Korean ones, there's Japanese ones. That has like 65,000 views. So we're getting a lot of people in. Now, I don't know about, if any of these people are going to be any good and are going to like be contributors or anything. But there's a lot of excitement around this. And then yeah, for the product launch that we have talked about, it's the chestnut, which is our eGPU DA. I want to make sure by the time we launch that the LLM app is pretty decent. So I think it's important that we do that. We have to like fix the pre-fill speed. We have to add tool calling support. We have to make sure it supports all the models people care about. Um, I think the overall speed is pretty good, but we have to make it clearer to people they have to use JitBeam. We should have better status updates during JitBeam. Maybe we could do a pass on Beam itself and make it faster. But yeah, I think this is pretty high priority for the company. This is how we're going to get a lot of people
Yeah.
using TinyGrad. This is like the first like use case, right? There's only going to be more of these that come.
I think we can discuss about because of this recent surge of user trying TinyGrad, there are also lots of like issues. We can discuss this at the end of the meeting to see like how we want to like handle these.
Oh, I haven't even like
Because
looked at
there
issues.
are a bunch of like things people trying different combination of the boards and the GPUs, and sometimes it fails with weird errors and things like that.
Interesting. I mean, again, I think a lot of it is we should really only support our external GPU dock. It hasn't launched yet, but I think what we're going to say is like, because a lot of this is probably just like weird broken docks and bad
Yeah,
cables and
yeah.
stuff.
I think it's more of a we just need to decide what we want to do and not having those issues hanging forever.
Yeah, I almost wish there was just a way to like put them in a big folder. Um,
Uh,
and anything that looks like AI wrote the issue or AI wrote the pull request, I'm done even reading these. I just write in all caps, do not use AI and close them. Like anybody who actually is so lazy that they didn't, it's bad enough if AI wrote the code, but the fact that AI then wrote the pull request, that's just a bar of like, no, definitely not. So
yeah.
how many of these have like the dumbass like Claude look to them?
I don't know. As for
I mean,
issues,
like
I think for
here's
PR
an
we can
issue.
close.
Okay, so like here's an issue that I think should just be like closed. This is not an issue.
Yeah, so those are questions, and usually what I deal with question is move it to discuss, and it will be forgotten forever.
Yeah, I think questions can just be closed. That's not an issue, right?
Yeah, yeah. So those we close, right? But there are kind of issue.
And now we have like here, this one, circular import error. Like we have like this issue. That's written by AI. Do not use AI. Close. Like, where do people get this template from? Like, this is some AI crap.
Um,
That's AI.
is it?
Oh yeah, without a doubt.
You are saying there's no
But
circular import if I try?
I don't know if there's a circular import, but again, my point is no human wrote this, right? You can see the use of the M dash, you can see the use of the yeah. I mean it's AI, right? You think a human wrote those arrows, which cascades through? Come on, no human wrote that.
Yeah, probably.
Right? And then you can always click on the person's GitHub and take a look and oh, it's their first issue. Great. Like, no. Right? Like we're not here to do customer support for people. We're here to just close all the low signal shit. People shouldn't be putting an issue. People should be putting now, let's you know what? Let's contrast this to good issues. Let's contrast this to the ones that right? Like this is a good issue. Right? So we can tell it's clearly not written by AI. It has a repro. It has a suggested patch. Uh, actually, is that already fixed? Oh, it's already fixed.
It's
Wait, so why was
but I feel like this issue may crop up in other areas. Like this feels like that happened to fix it, but I didn't close it because I was like it seemed like this might be a bigger issue. Like this
well, I mean,
specific repro doesn't.
I think the Claude fix is largely correct. We just need to make sure when you pickle, it creates new unique.
Yeah, it's mostly correct. I think if you were to pickle two objects containing the same unique and then load them both in the same like and then load them both as separate things in a different process, then they would be different uniques.
We can get to the specifics of this later, but just to talk about like what good issues are and what bad issues are. Anything that's AI or a question should just be immediately closed. Same thing with the PRs.
Yeah. Okay. Still,
Like
there are some of the, I think most of this Mac and some kind of GPU. We still need to find a way to deal with those.
well, I mean, some of the yeah, I agree. And if we can like find something that we can actually reproduce, then let's do it. But like here's an issue with like RDNA2. Yeah, RDNA2 is not support.
Now we can say we don't support.
So Nimmelgen, I see you replied to that. Just when you reply to it, just close the issue. RDNA2 is not supported. And I think we should update our docs to make sure that that's clear. Right? Like some of this stuff needs to just be setting expectations for people. Yeah, no, I mean, yeah, I don't know if we can like. I've seen some GitHubs that have like I've seen some GitHubs that just turn issues off entirely. I don't think that's the right idea. But if we can put some like banner on top of issues saying like questions will be closed without comment. Anything that's written by AI will be closed without comment.
I don't think those banner really stop people from posting AI slot.
No, it's not gonna.
If you are capable to read banners, I think you will have more social
Well,
capability.
no. But the point of the banner is not to stop people from posting AI slop. It's just to communicate to everybody, mostly even here, that that's our policy about AI slop, right? It's not about stopping people from posting AI slop. It's just so like the thing about AI slop is like it's not actually that bad as long as you immediately identify it and click close on the issue. You can deal with this all in seconds. But if you have to spend time and you read it and you treat it like it might be something real, then you know they got you. A machine is wasting your time.
It's never a machine waste your time, right? It's another human waste your time. I
Well,
don't think
the
I don't
humans
think
use
cloud
the machine to
automatically
waste your time.
generate these. Okay, anyway.
True.
Okay. Anyway, another thing is because these like hanging issues would likely to go like
Agreed.
that's another reason I don't like these hanging around. Okay, we will see. I think as we have like more adoption, we will get used to some of these.
I went through pull requests yesterday. We have a lot less pull requests.
Great.
Yeah.
Okay, sounds good. Wait, what? Okay, let's move on. Oh, that's it. That's it. All for company update.
I think so. Yeah, gonna start building out the Xbox this summer. Build out the first Xbox. Yeah, and we got to make sure the eGPU is good for comma and good for our use. We'll do. Yeah, I mean, so I'm back in San Diego in May. The main thing that I want to do is just make sure that our Chestnut launch goes well. I want to make the LLM app more usable, and then I want to test it on a large variety of hardware and like really stress it. We have every GPU, we have every USB 4 port, every USB 3 port. We just need to test all this stuff.
Sounds good. Okay.
I also think we're going to sell a lot of these, right? Like, look at all the people who watch these YouTube videos. And we're pricing it at a price point where it's the kind of thing that people are just going to click buy on without thinking too much about it. Like, the beauty of $200 is people just click buy.
Like my rabbit.
Exactly. It was $200. So you just click buy. You don't use it, you just click buy.
Okay. Great. Anyway, let's move on. Let's start with actual items. The first one, I just reversed from the last time. So first one, let's start with the new dev. Chris.
Yeah. So so changes to there's not all that many changes to dev now that it's kind of mostly solidified. Mock GPUs and interface. And I started moving some stuff to actually use Arch. So you can now you can now specify like all of your feature flags in CPU, which is kind of cool. So the way that works is you specify like the architecture, but then you also specify the CPU that you want to do your tuning for, and then you specify the flags. And then you can just like put native, and then if you put native, then it'll figure out for you what you have available.
We have docs on
Um,
this anyway?
yeah, sorry, I gotta write docs for that. There are hopefully useful error messages, but I will document that as well.
Right. So this is for things like AMX.
For right now, it's just for like AVX or AVX2 or AVX 512. But I will put AMX in there as well. There's some sort of question about like, okay, well, do you want to make AMX on by default? Because changing it is then now a little bit annoying. So if you want it to be the non-default value, it's a little bit verbose to change it compared to just saying like AMX equals 1.
I mean, we want to get rid of all of these flags, right? Uh, most of the point of the dev project is just to kill off all of the hidden environment variables.
Yeah,
So I mean, I think the way to do it, yeah, sure, it could be on by default, but you just want something like minus AMX or something.
yeah. That's the way it would look. The only thing that's worth pointing about AMX is that AMX also refers to some other thing for Intel, which is a little bit confusing.
I'm aware.
So I guess
Yeah.
yeah. But I was
I'm
just
fine
thinking
with calling it Apple AMX or something.
Apple AMX. I would also like all caps AMX also would work. Anyway, either way.
Oh, speaking of all caps, so I just read the CPU renderers use Arch thing.
Mhm.
The CPU Arch is all capital ARM64 on the Qualcomm Windows computer. So just
Oh,
add a
okay.
dot lower there. Yeah, just make
Okay.
sure that's
Yeah.
canonicalized. I see like AMD GPUs in caps, so if you just do Arch dot lower and yeah.
Yeah. Sorry, I didn't realize. It's like different on every machine. It's kind of annoying.
Yeah, I was testing, and the Windows one has bugs too. I posted about this in
Oh, yeah.
failure, but yeah, but regardless, yeah, that was the only actual bug I had to fix to get it to run.
Okay.
Um, cool. And then yeah, how much more? So does mock work?
Yeah, mock works. So you put mock PCI or mock KFD or mock USB on AMD, or on NVIDIA you can put mock NVK.
Okay, so so just dev equals mock PCI plus AMD.
Yeah.
Test tiny. Okay, this failed because there's no module named test. So I need Python path. No, I'm seeing all kinds of crap about. It seems fine. This is probably unrelated, but that's the error I get when I do that.
Oh yeah, this is I thought someone opened a PR about this, or maybe an issue. We just need to suppress warnings in Dell. I think there's a PR open for this that does this.
Right. But yeah, no, otherwise, yeah, mock PCI plus AMD worked. What does mock USB do? So like put it through the whole USB path?
Yeah.
I see. Should there be a default mock?
I mean, it's kind of unclear what you want. I thought about this, but I kind of felt like it was better to be more explicit. But
Well, yeah, okay, I guess that's fine. I mean, because normally you're putting yeah, that's fine for now.
yeah. Oh yeah, there's also mock CUDA, which you just put mock plus CUDA, and then that does the GPU ocelot.
Oh, so it's just mock plus CUDA.
Yeah.
Okay, so I'm getting that doesn't work for me. I get invalid value for GPU architecture.
Oh, wait. If you're running on the same computer, it says you couldn't find libGPU ocelot, although that is not a good error message.
Well, I mean, I don't even think that's what the problem is here.
Okay, I'll take a look.
My guess is the problem here is that I have a version of CUDA that's too new to support the
Oh
mock.
yeah, you're right.
Um, for AMD, I mean, I kind of would like there to be a default mock.
Mm-hmm.
Is it easy to just alias mock PCI as the default mock or mock KFD, whatever the like, because
Yeah.
it doesn't. Yeah, like what's the simplest mock?
I think it's KFD. I think KFD is the simplest one.
Yeah, then just alias that to
Yeah, I can do that.
whichever. Yeah, whichever. It seems like it runs the fastest. Great.
What else?
Yeah, because I expect that mock plus to be able to work without having to think about like, what is the mock for, right?
Yeah, that makes sense. Yeah.
But no, I mean, it's great. It's great that like this is now a simple way for everybody who doesn't have the GPU to basically test the entire flow of that GPU.
Yeah. What else? Yeah, so the other thing, I guess we can talk about this more probably later if we're gonna talk about JIT stuff changes, but definitely run into some regressions here. Especially so if you load a pickled JITted function now, it recompiles everything. And for one, this broke no locals. So if you have a no locals function, and you JIT it, and then you pickle that JIT, and then you load it in a separate process, the no locals optimization will no longer be applied. There's that, and then also just this is a confusing. Maybe it's correct, but we still should probably have a way of being able to save functions that are compiled such that you can load them later, because this is definitely a feature that Common wants to have.
I see. Yeah, so this is the like linear JIT stuff causing these
Yeah, yeah.
regression. Got it.
But we can talk about that later. That maybe is not for right now. Yeah, other things are num GPUs. I'm adding this, but it's maybe like a dot count. That also makes it easier to put nicer error messages that aren't just like list index out of range. Should be good.
So it's going to be like device sub AMD.count.
Yeah.
Yeah, that's good.
And then the other thing that's worth pointing out there is like right now we don't support multiple USB GPUs, but I think there's not really any reason that we couldn't. We just have to we have to actually traverse the tree using libUSB as opposed to just doing like, get the first one.
Cool. Yeah, no, I mean, I think those are important things to support before we launch testnet. Want to make sure that we're okay. Cool.
I think that's it. If there's anything else that people are upset about with respect to dev, let me know. But yeah.
Sounds good. Oh, we might want to also update the Python-m tinygrid.device thing. See if we
Oh,
want
yeah,
to add anything to that.
Yeah, interfaces would be good to add to that, and count. That happens.
Okay, next is Llama.
Run linear also regress something for llama. I have a PR that fixes it. Basically, the linear holds reference to all the calls, and then this just doesn't free anything between batches.
Oh yeah, I mean, this has always been a subtle bug where this is why, like, if you read the old exec item code, it would pop things off the list.
Yeah. But my PR basically matches the old behavior of popping the calls.
Yeah, I think that's probably fine, right? Like, yeah, so I see what it is now. Like at the end of realize.py, you have recall and linear source. But yeah, I mean, you're passing in linear as the UOP. What you want buffers to be freed?
Yeah.
The solution probably isn't to delete the UOP. The solution is probably to free the buffers.
We explicitly free the buffers?
Yeah, probably. I don't know. Annoying. I don't know, but yeah, that's been there should have been better regression tests for that because that's a known problem. Maybe Nimmelgen has ideas about how to fix it. But yeah, we'll get to that. How's Llama going otherwise?
We saved another 30 minutes. It's getting much harder to find places to save because now all the kernels are fairly fast. I guess there's mostly just kind of the long tail to chop, but it's very unclear what a lot of the long tail is doing and whether or not changing stuff there actually saves time.
Well, so how much will be fixed when we fix the linear regression?
Linear regression just speeds up eval because I can work around the linear regression by dropping eval BS to 8.
I see. I mean, yeah, we should probably even free the whole. We should be more aggressive in general about just like freeing things in between jets, and it should hit the LRU cache. We'll talk about that when we talk about jet. So what is this? What is this long tail? Are there still an absurd amount of copies happening, or? And how come you said we're at 3 hours and now we're back to
So
we're getting
this is the whole NAN being fake performance thing that I found. Seems like NANs take a faster path out during matmos, but we don't hit PPT power throttling if we train with fake data because it's all NAN.
we make the fake data not NAN?
Yeah, I think so. The problem is we have to make the weights not NAN. And currently the weights for fake data we just assign tensor.mt.
Let me see. Yeah, how
You
fast
can
is
have
it trying to
you
deliver?
can have some legit init, no?
Is it fast?
Yeah.
My proposal was you can certainly try the same init weight that's legit and having like a very small
Very
learning
small
rate
learning rate, yeah.
to just if you want to just test this hypothesis.
I mean, yeah, we should figure out. I want the profiler to be actually reflective of what's really going on.
Yeah.
I don't know. I mean, it looks like there's still a lot of slow kernels. What's the latest from the profiler?
We're at. I've been using my profiler. We're at this.
Why are you using your profiler and not the other one?
This basically just splits it by category.
See.
It's a little more obvious to me when I'm visually looking at it to see that what is slow.
I mean, we'll talk about this when we talk about Viz, but okay. So the step time is 1.5, 1.7 seconds. So you break down copy. Shouldn't all the copy be overlapped? Is that overlapped copy or non-overlapped copy?
This is non-overlapped copy.
Why is all the copy not overlapped?
This is not all the copy. This is explicitly the non-overlap copy. There is copy that is overlapped. There's a lot of copy that is overlapped.
I see. I mean, why is all the copy not overlapped? This is data parallel.
Yeah. I guess all the copy should be overlapped.
All the copy should be overlapped. Well, okay. So then what's the total number of steps we gotta do?
6,250.
6,250 seconds to hours.
Somewhere around there.
So that's 3.04 hours if you go with that timing. If we're talking about just this, so we're not going to make the gem and the flash attention faster. I think that's just what it is. So if we're doing just the gem and the flash attention, we're looking at 1.5 hours. So we got to fix this other crap.
There's a lot of kernels in other, but also a lot of them are real kernels.
Well, so I see you say this fused silo mulcast AMAX W13. What is that? Where's that name coming from?
I don't know if this one's in master. I'm on a different branch where I'm just testing a bunch of stuff.
Safe. Well, what the way that I'd really like to deal with these other kernels is I want some agentic loop to just do it.
Yeah, that's basically what I've been doing.
Yeah. So I want this stuff to be fast enough. Hopefully, I mean, we talk about Fizz next. This is the main thing I want to talk about. I think that there is nothing fundamental about these other kernels, and what I want to do, what I want everyone, this is kind of related to the dev stuff too. I want to make sure this is related to dev stuff, this is related to JIT stuff. I want to make sure that agents are capable of replacing stuff with hand-coded kernels pretty easily.
Mhm.
Because I think the solution to this isn't for us to start writing each one of these kernels. It's to have
Mhm.
agents come in and just, oh, well, okay, yeah, I'll rewrite that as this, I'll rewrite that as this, I'll rewrite that as this, boom. And then, but the copy thing, agents aren't going to be able to fix. Like, I don't understand why that we have to fix ourselves. Yeah, we want the APIs to be really good and simple and predictable, such that agents can come in and make all those other kernels fast. Also, if we still have a lot of useless copies, we should figure out why Rangerfly is not optimizing them out, which is another thing that agents aren't going to do. But what we should be able to trust agents to do are to make kernels fast. Like the end solution. When I talk on Twitter about how TinyGrad is going to be 25,000 lines and have beyond state of the art performance, look at that gimme graph. Like, this is how we're going to do it. We're not going to do it all of the time that humans have spent on stupid heuristics over and over again to try to make these things fast. And that's what like all of the millions of lines of CUDA and HIP are and stuff. It's all going to be replaced by AI. It's all going to be replaced by exactly what that agentic loop did. But the things that AI will never ever be able to do is like scheduling at a grand scale. That's the kind of problem they're just not good at, and they probably will never be good at, because it's not like it's the other kind of. The reason the LLM inference thing works like the way it does is because the problem is a convex search problem. If you make the problem a convex search problem, AI is very, very good at it. If you make the problem well, you have to actually uncover this new thing and you have to try down this route for a bit, and then it'll never figure it out. Right? Or to say what Terrence Tao said, he said, LLM, AI can jump, it can't climb. So yeah, we have to make sure that our APIs are really clean for agents to come in and write all the kernels.
So let's start with JIT first.
Yeah, so for the compile issue, yeah, it's possible to fix. I just thought that maybe we like want to have this cheat capture to be portable, but basically the solution here is to decouple get program actually just to compile things into the program.
So I'm okay with you making the change to where it does all the compilation up front.
Yeah, okay.
Like, I know right now it's still doing the compilation one at a time. Right? Like in exec kernel, it's calling get runner. We should do all of that up front, right? That should actually be part of the rewrite itself.
Yeah, I mean, I just simply can have a pattern matching to just call the to program and basically replace syncs with programs.
Exactly. Yeah, like we should do that. And then I still want to fix the I think how is the fix of the HIP compiler thing in example 2 HIP going? Like, why is this still required? This should be done by the lowering pipeline.
Oh. Yeah. Yeah, I should look at this again, but yeah, I had it's last week when I looked at it, it seemed like it was a lot of that code was sort of moving around. But I'll look at it again and see what I can do.
Yeah, I mean, this is there's a cross collaboration issue. I think Imogen, it's mostly yours. Making sure that the new stuff should just call lower program in the graph rewrite. And we need some way to get performance. In the context, there should be a TQDM that says how many compiled things there are. And then that one can call like update on it and stuff. That make sense?
Yeah.
So we put a TQDM in the context for every program that's lowered, right? Like we need to, this should have been done a long time ago, and I blame myself for it. Like I had this idea of like, oh, it's so nice. Look, everything is lowered right on demand. But the whole thing has evolved to just not look like this. The major graph rewrite could rewrite all the syncs programs. And that should, we just need to communicate that status a bit better. We also need to communicate the status better if it's doing beam, and this should be enabled with debug equals 1.
Okay. Yeah.
I think it'll be great. Like debug equals 1 will just say, okay, need to compile 67 kernels. Great. Okay, 0 to 67, 1 to 67. Compiling includes the beam search. Done. You have the beam in the graph working?
Yeah. So actually, that's the only problem is with no locals because, yeah, they are not in the graph right now. And I know if we want to put them.
Problem is with what?
No locals.
Oh. Yeah, it could be kind of like beam, I think.
Yeah.
What is no locals really? I don't know. I don't. How much does it regress performance if we delete the locals?
I think it regresses performance a lot.
Okay. I mean, I hate that there isn't even an exact answer, right? Like, I maybe we just need a better way to express the only reason no locals really needs to exist is not because of the search. Like the search needs to be deleted. That search is ridiculous. It needs to be deleted. The only reason no locals really exists is because you can have like fractional things, right? Like I can
Yeah.
have G equals 63 while L equals 16, and it'll just know automatically not to run that last one. So I don't know. If you want to, is it easy to hack in just like Beam?
I'll take a look. Yeah.
But I think this is great. I really like the direction things are going here. And yeah, now with the deletion of so like I see this add beam thing. Where does the beam search actually happen? How come I don't see that in this?
So it happens at the same place. Like get programming down to the rewrites.
Even if I do parallel equals yeah, I see. Okay. Yeah, I think we just need to move all of that to the graph rewrite. And
Yeah.
like sort of precompile everything. Yeah, that'll
Yeah.
be.
So
Right.
yeah. So actually the status is actually the run linear is now used to execute both in the schedule and JIT. And I still need to refactor graphs because they still use exec items, and after that we can delete it.
Right.
So they just use exec items to build graphs right now.
Yeah. The deletion of exec items great, and I think combined with this refactor, it just becomes very clear what the difference is between the whole lowering pipeline is just one lowering pipeline. It's not. There's no such thing as compiling and rendering and all of these things. It's just, okay, cool. Return your tensor graph into a large binary blob that works on GPUs.
Yeah. Yeah, I haven't. Yeah, I haven't really looked into the CI issue with framework machine. I'll do this week.
Great.
Okay. Next up is Viz.
Just merge the CLI. You can try with Python-m tinygraph this CLI. If you add debug, it will reconstruct the complete debug output.
Great. Oh, I see. You just literally just merged them.
Yeah, just merge them.
Okay, so select a source
Can
profile.
A-S all.
I see. Okay, so now it kind of like it shows the debug equals 2 stuff. Okay, I kind of like that. Let's see. No underscore color equals 1. Let's say. Yeah, so that shows me those things. Okay, now I can select an item, which I assume is just the name. No, that doesn't work. Okay, so this just violated my expectations. How do I use that? -I?
I mean, the expectation is that you grep in the profiler.
What? How do I print the
And
source?
then
How do I
I
print
you
debug
get the
equals 4?
source.
Yeah.
Oh, you just put
Oh,
debug
okay.
equals 4.
Put debug equals 4. I see. What if I put debug equals 1? Okay, it still prints things.
Yeah, so
Okay.
the default is debug equals 2 style, and then you can go up to debug equals.
Why would I put debug equals 4? Did it load all of these libraries?
So you want like dash debug, or
No, I don't know. I
maybe
just
like
don't know why it loaded. No, debug equals is fine. I just don't know why it loaded all the libraries.
I think because of the import, like pickling. Can maybe disable debug and pickle. Yeah.
Ooh, did you mean split ranges? Ooh, that's pretty nice.
Oh yeah. There's a did you mean, because LLMs often sometimes
Yeah,
put
yeah,
the
we'll do
wrong
it wrong.
thing. Yeah.
Okay, so how much stuff is replicated here? Like how much code is shared and how much code is replicated?
VisCli shares everything with this server. The only thing it adds is printing. And like the Vis
okay.
server just encodes the stuff. So there's a decoder on the CLI side. Just
Okay,
like JavaScript. Yeah.
that looks pretty nice. So I see a very fundamental difference between this, like I almost don't expect this like 2-layer thing where there's like the profile and the rewrite.
Well, they're fundamentally different. Or maybe like it's just get program. And you put the rewrite and debug equals 4 of get program.
Yeah, maybe. How come those things don't line up? Delay is too large. And how? Oh, so delay is. I see. Delay is how long it takes to get the packet.
Delays the time between issuing and actually executing that thing.
I see. All right, cool. How good are LLMs at using this?
LLMs are very good at using the profiler now, since Friday, because they added JSON support. They just put the file in a JSON and then you just crack on the JSON.
What's JSON L?
JSON L just means line, but you can put JSON and it will work. Like this is arc parse niceties where both JSON and JSON L were produced.
Yeah, I wouldn't even call it JSON L. I would just call it JSON. But all right, so I'm trying to use JSON and I don't know how. Like, I put JSON and it still gives me a list here.
In the SQTT. Right?
Not SQTT. I don't know. Oh, I'm supposed to know that's related to SQTT?
No, it will always put JSON, but not in the list, right? It's like dash s all or something. I should make
Okay,
dash s all default, but then SQTT will get.
Yeah, okay, I see. It definitely shouldn't be JSON L. I have no idea what that means.
JSON will work too. Yeah.
I understand that it works, but that shouldn't be what the help thing is, right? Like, I'm confused at that, looking at that as a human, and LLM will be confused as well. Okay. Profile path, rewrite path. So I actually think that those shouldn't be separate options. I think that that should just be like dash P and then the path, right? Like dash P and then have an optional path.
Mm-hmm.
Oh, but yeah, I mean, fundamentally, this comes down to like I'm just trying to behave like an LLM here as best as I can. I'm just like trying things, and yeah, I mean, fundamentally, this comes down to like how good LLMs can be at using this. I kind of want to replicate that. Uh, do we have M3 Maxes?
I do.
You have an M3 Max.
Yeah.
Great. Can we replicate that Kimmy thing? It doesn't matter. It's not an M3 Max. It can be on anything. But I want to basically replicate, like, can we keep an agent running for 12 hours? Where we can also use, I have Kimmy 2.6 running on AMD 2. Just use a normal 7900 XTX. But what I want to replicate is being able to have an agent run for 12 hours and make continued progress. Like, I think that's I think that is the culmination of this Viz project. Replicating that Kimmy graph. Make sense?
Which Kimi graph?
Oh, I posted it
inference?
above, but yeah.
Yeah, the inference one. Okay.
Yeah, so they had something run for 12 hours that just it used Zig, but it should be able to do this in Tinycrad too. Like, it should be easy enough for it to create custom kernels in Tinygrad, for it to control the fusion, all that stuff.
Do you control the fusion?
Yeah, we shouldn't be using M3 Max. We should be using 7900 XTX, where it can do business stuff. How do you control the fusion? That's a good question. You write the stuff in UOps.
Yeah.
Yeah.
Do you actually think they're capable of it? Because every time I've been trying to get LLM.c and sorry, LLM app be faster. It got it to like 111 tokens per second. with like adding contiguous and stuff.
Yeah, I mean, so there's a few like things here, right? Like we have to kind of like I think the way to do this is to like do one by hand, and then LLMs will be able to do the rest. So I mean, it's kind of the thing that you've already been doing, right? The same way you do like the FPA kernels and stuff. Like maybe you do the fusions for one of these LLMs manually. And we need to show the LLM that you can code kernels in like multiple different ways. You can either code in, and this is like what abstractions for is. You can either code in Tinygrad, you can code in UOps, you can code in IP, or you can code in assembly.
I think the place where I saw abstractions for breakdown was when I actually told it to like look at LLM, it didn't comprehend the fact that Tinygrad will deal with like the contiguous. It felt like it had to like fuse the entire dequant with the FFN.
See.
And it's like, this
Um,
is too hard. I have to change the GGof. Like there's all these like randomness that comes in when you actually put it in the hands of the agent. So I think I have to do one manually, like maybe the Quen one.
Yeah, and then like you do one manually and you use these tools. So also, Woes Parrot said that he wasn't using your profiler, he was using his profiler because it does this classification. What can we do about that?
I'm
How can
hoping
we,
JSON will fix those. Like just
how does JSON fix it?
because like I try to make the profiler very generic. Like it will output basically, basically like a debug replayer. It's not gonna categorize stuff, but it will print all the markers. Like, okay, this place there was a marker for a train step, and there's all these AMD devices, and there's a tiny device. So the agents are very good at taking that JSON and then piping it into some Python. I think I'm happy with that. Because the main thing the Viz profiler is solving is stuff like relating the timestamps and making sure those are right.
Yeah, I think you know what your project is for the next couple weeks, and it's just basically to replicate that Kimmy thing, make sure that they can use the profiler. And yeah, we shouldn't be using M3 Max. We should be using RDNA3, and I want to go like beyond. I want to get Quen at the memory bandwidth limit.
It needs mega kernels. I mean, like, I looked at it, like, it needs mega kernels, which is fun.
All right. Well,
What?
we shouldn't be writing those ourselves. We should be having the LLMs do it. I think Kimmy can implement it stuff.
Writing mega kernel? Yeah.
Kimmy can add support for itself. It's trying right now.
We
They're good
need
at
to.
small rewards, not big rewards. They want to see big progress with something that has already existed.
Yeah, but it also depends on what the actual progress will look like. If you are at like every kernel just need to be 20% faster, there's no big jump, right? If you only have a handful of slow ones, maybe. That seems to be like mapped to that actual graph. There's a one very big jump in the middle, and the rest are more of like incremental.
Yeah, I mean, I don't know where we already are at on that graph, but like eventually the way that I see this working is like, it's called like Hyperbeam, and we run Hyperbeam, and Hyperbeam goes in and rewrites all your code for you.
Great. Okay, let's try to speed up a little bit. And next we have the LM app.
Yeah, we quick. Yeah, so I moved the LLM app to the LM directory. Just did a bunch of refactors on it. I'm gonna move GGUP to LLM loaders. We'll be able to have some other loaders in there too. Look, like, is an LLM an application? Like, should an LLM be in the TinyGrad repo? And my argument is absolutely yes, because eventually Hyperbeam itself is going to use the LLM, right? Like the LLM is a part of TinyGrad. Right, oh, it
Is that a good
is.
argument? It's like, do we include cloud code or code base?
We include which?
Include cloud code to TinyGrad?
Some limited version of it, I think so, yeah.
Okay.
Not
That's
Claude
fine.
Code. No, obviously, we're not trying to build a user-facing thing, but what we are trying to do is make the LLM. This, I think, this agentic thing is like, it's cute and that it can like call things, but like realistically, that's not what you like care about. Right? You don't want it to be able to call any bash thing on your system. Not only is that crazy and secure, you're asking like also why is it capable of doing that, right? Like, eventually this stuff will be the loop will be, clear what you can do. And all the kernel optimization should be exposed kind of as tool calls to the LLM, and the thing optimizes itself.
Great.
But you have Qualify on here too. Did I do something with Qualify this week?
Oh, I just saw you move something around. If you want
Oh,
to say anything before
yeah.
you do anything.
Yeah. So I split call into two things. I split call into function and call. A function returns something and a call doesn't. That's really the only difference. But I found that they were just used completely differently in the library, and whenever that's true, you should just split into two ops. So function is just like think about it just as a straight up substitution, and call can be something like a program. A call doesn't return anything. A call has a sink. A call has side effects. A function, that's the difference, basically. A function doesn't have side effects. A call has side effects.
Okay.
Um,
Anything to say about the highback? I think the broadcasting is probably fine. I don't have huge opinion on that.
yeah, it's very slow going. Takes a long time. I've been spending a lot of time just like drawing things on the board. But yeah, I think I know how to do it. It's not very complex. It's almost going to delete. It deletes the entire expander, and then it simplifies the devectorizer. And then like we have a lot of repeated uops, right? Like JEP shouldn't exist. JEP should just be index. And like those other like even more ridiculous ones like pointer cat and broadcast. And I think we have broadcast. It should always be deleted. It's just moving opposite. We need to add cat, but other ones.
Yeah, one small thing to note before you add any new UOP methods. We now need to be careful that the name doesn't collide with some actual tensor function then that we want to use. So, for example, invalid, I need to change one of it, something like that.
I see. Yeah.
Yeah.
Is there a way to have a linter fail on this?
No, I mean, it would be obvious once the mixing is done, right? Because every function they share would be shared. It's just now in the middle of the migration, you will see like it collides with existing stuff.
Got it.
Okay, I'll be fast. So tensor UOP mixing. Really now the only bottleneck is the full one, and because of the unique const, you can see my latest thing that I will think tomorrow. I might just merge that. I try the copy on write and different version of injecting the unique, and all fail with other different reasons. So at the end, I think this is probably good enough.
Yeah.
And with
That's
that
fine.
move, that just unlocks the A range and pretty much everything that builds on top of A range. And I think at the end of that, that should be it. For now, I still keep some of the. I keep the window graph count still in tensor. I keep all the image stuff still in tensor. We can decide what we want to do. I think window graph we eventually want it to be a rewrite in somewhere in Rangify, so I don't see like moving that into mixing. Image, it's I don't know. I don't have a huge preference.
Why are like cast and bitcast still in tensor?
Because they mean slightly different things.
Mm,
This is the same thing for the div and mod that I think I will leave at the end because these are
Okay.
kind of we will find a way to clean these up. Not like actually we need to move it.
Yeah,
But
I mean,
yes.
I want these to sort of be unified.
Yeah, so I think the way to do that is this will be unified. I also want to do that. It's just there's not a clean way to do it yet.
Yeah.
Yeah. So div and mod is slightly more annoying because in tensor level there's no mod. Mod is only introduced later, but in the UP we sometimes call the mod directly, and sometimes we want the other form. So these are minor annoyance. We have several very basic fundamental blocks that in UP is really overloaded, and in different stage we want it to be different things.
What do you mean? There's definitely a mod in tensor. I wrote a quadratic sieve with this last week. There's a mod.
Yeah, but that mod is it's using div. It's not upstar mod.
Oh, I didn't know that. Interesting.
Yeah, it's a minus a div b multiplied by b
Yeah.
because in UP the mod and div is c div and c mod, but in tensor it's not.
Yeah. Yeah.
So there's two other ones that is slightly annoying. So anyway, these fundamental blocks, I think it's fine to leave at the end of this and move the other things that has real function. Yeah, so that's pretty much it. I will think about your other proposal of variable after maybe next week. We can discuss about that.
Yeah, it's very confusing to use. I think it should kind of just be tensor, and we should like work on scatter and gather like being good.
Yeah, sure.
Like you should be able to scatter based on like a math thing with a range, right?
That is only good if it's a range. That's the annoying part, but sure, let's discuss this next time. I also think about this a lot.
Sure. I mean, you should be able to multiply by 2, or you should be able to scatter on an index tensor times 2 or something. We shouldn't have something special called variable that you can scatter based on, or maybe you can already do that. But I don't know. I wrote the quadratic sieve stuff, and wow, Tinygrad is fast. And I don't think any other library can do this. And it's fundamentally because we confuse like math and a reduce.
Great, sounds good. Okay, we go a little bit out of time, but I want to quickly discuss like how do we make Karma happy?
I see Torque Boy in here.
Yeah, he also just post his thought on stuff, right?
Yeah, we gotta address that. I mean, we fixed one of the issues apparently. Apparently, we are fixing the issues.
The other thing that I think is probably an issue for Comma is the fact that we're downloading AMD firmware. Probably need to figure out a better solution for that.
Yeah, I'm supportive. You want to take that project after
Yeah.
the dev and the abstractions clean up? Yeah, I think we just need to like figure out how we want to like auto gen or something. But we shouldn't. The internet should not be a requirement.
Yeah, for sure.
Yeah, we got to auto gen without these files being massive.
Yeah, the headers for sure. I gotta think about the binaries, but yeah.
It's the binary firmware that's the annoying one.
Oh, Yeah, I don't know. I don't have an obvious solution for that.
I think generally just something good is they say they waste like hours of to do something, right? And it's not clear if it's because TinyGrad is still alpha-ish, as like brittle and things are like changing. If that's the case, maybe it's like, okay, we will fix your issue. But just generally, given that other external user who tries to use TinyGrad would probably just get a much worse performance, we will use this as like see where we can maybe it's just having better error message, maybe it's just no, something.
Yeah, I mean, as we get closer to implementing the spec, I think like, you know, mixins. You saw how I eventually think that mixins are going to create functions, right?
Yeah, it's like that's kind of how I write this. So tensor will be just a thing like entry point.
Yeah, and then it'll unpack the
Maybe
UOPs and
re-
it'll wrap UOPs in a
Yeah.
function, and then that's metadata basically.
Yes.
I think when we have all this stuff, like this is how we can really improve our error messages and our 1.0 is in sight. It is still years away, but probably not 3 years away.
Okay. Anyway, I think we have enough resource to help out with the comma issue, but on a more meta level, just take these as opportunity to, I think one is to see how cloud can help issues with TinyGrad dev faster. I think comma is already using that. Then second is just find a better way to not waste their time and not waste our time, find a balance between this. It's just sad to see that your user says they waste tons of time. So let's try to not to do that.
Yeah, at least hopefully it wastes Claude's time.
Do you want
Okay.
to merge my USB tuning changes?
Oh, yeah, you don't have access to repo?
No, I don't.
Oh, I'll just add you.
Great. I think that's it for today. And for everyone here next week, I will post since it's a new day, I will post maybe the day before or something like that. So, the day before also happened to be a Monday, so you will see. Okay. I think that's it for this meeting. Thank you, everyone. See you next week. Bye bye.
Thank you.